In this video, I shall be discussing about imperfections in solids. Okay, let us first know what is an ideal crystal. Okay, so in any ionic crystal which have the same unit cell containing the same lattice points throughout the whole crystal is known as ideal crystal. Okay, now let us see what is disorder or defect or imperfection. Okay, so if there is any deviation from a completely ordered arrangement in a crystal, that is called disorder or a defect or imperfection. Okay, now there are two types of imperfections, that is electronic imperfections, and the second one is atomic imperfection. It is also known as point defects. Okay, so the first one is electronic imperfection. Now this corresponds to defects in ionic crystals due to the electrons. Okay, the perfectly ionic or covalent crystals at 0 Kelvin have electrons present in the fully occupied lowest energy states. Okay, but as the temperature increases, the electrons may occupy higher energy states, okay, which will result in the free movement of the electrons, and hence the electrons are responsible to conduct electricity. Okay, now if on increasing the temperature of that particular crystal, the electrons are excited to a higher energy level, okay, and they are free to conduct electricity. Hence, if the electron starts moving from a particular point, then the vacant space or the vacant point created by the electrons will be called as holes. Okay, and the holes are also responsible to give rise to electrical conductivity. Okay, but the direction of the motion of holes in electric field will be opposite to that of the flow of electrons. Okay, now such free electrons and holes in crystals are considered to be electronic imperfections. Okay, moving on to the second one, that is atomic imperfections or point defects. Now these defects, okay, arises due to irregularity or deviations from the ideal arrangement of atoms around a point or an atom in crystalline substance. Okay, now the defects which arises due to irregularities or deviations from ideal arrangement in entire row, okay, of lattice points, they are called line defects. Now these point defects or atomic imperfections can arise due to any one of the following causes. The first one is the vacancy defect, okay, which means some of the lattice sites are vacant. Okay, now the next point, okay, the next cause can be of the interstitial defect, which means when some constituent particles occupy the vacant interstitial positions. Okay, such cases it is called interstitial defect. Okay, now these point defects in ionic crystals may also be classified as following. Okay, that is defects in stoichiometric crystals, defects in non-stoichiometric crystals, and impurity defects. Okay, let us see one by one what it says. Okay, the first one is the point defects in stoichiometric crystals. Let us see what is meant by stoichiometric compounds. Okay, stoichiometric compounds are those in which the number of positive and negative ions are exactly in the ratios indicated by their chemical formula. That means suppose H2O, okay, in actual the number of H will be equal to the number of O, okay, that is of the ratio 2:1. If it is NaCl, then the chemical formula says that the number of cation and anion are 1 each. So in actual there will be also 1 cation and one anion. That is what it means by stoichiometric compounds. Okay, and if any defects arises in such compounds, then it is called stoichiometric defects. Under stoichiometric defects, there can be two types, mainly Schottky defect and Frankel defect. Let us see what is Schottky defect. So this Schottky defect, it arises if some of the atoms or ions are missing from their normal lattice sites. Okay, and hence they create vacancy or holes. Okay, now in this case, since the crystal have to remain electrically neutral, therefore equal number of cations and anions are lost. Okay, and hence the density of that particular crystal decreases. The crystals which undergoes Schottky defect are NaCl, CaCl, KCl. Okay, these are some of the examples of Schottky defect. The reason or the cause of Schottky defect is because of high coordination number and ions of almost similar sizes. Okay, the next one is the Frankel defect. It arises when an ion is missing from its normal position and they occupy interstitial sites, that is the point between the lattice points. Okay, so here the normal position where the ions are being present, they used to go away from that place and they occupy the spaces in between those normal lattice sites. Okay, that is called the interstitial sites, and hence it is also called as interstitial defect. Now in this case, since the ions are not lost, only thing is that they are displaced from one point to another point, therefore the density is not affected. Okay, and some examples of this Frankel defect, again where we can find out the Frankel defect, are AgCl, Z and S. Okay, and even AgI. So the reason for this one is because their coordination number is low and the anions are much larger than the size of the cations. Okay, the next one is point defects in non-stoichiometric crystals. Let us first try to know what is these non-stoichiometric compounds. Okay, the compounds in which the ratio of the positive and negative ions present in the compound differs from that required by the ideal chemical formula of the compound are called non-stoichiometric compounds. For example, let us take FeO. Okay, the ratio is 1:1, but in actual the ratio of Fe is not exactly 1, but it is little less than of that 1, say around 0.93:1. Okay, that is the ratio of the FeO. Okay, so such are the non-stoichiometric compounds. Now if any defect arises in such compounds, it is called non-stoichiometric defects. Okay, now there can be of two types under this non-stoichiometric defects. That is one, that is metal excess defects, and the other one is metal deficiency defects. In metal excess defects, there can be of two types: anion vacancies and excess cations occupying interstitial sites. So let us see what is anion vacancies. Here the negative ions may be missing from their lattice sites and thus they leave a hole. Okay, or they leave holes. Now in those holes the electrons are entrapped, okay, or trapped in order to maintain the electrical neutrality. Now this type of defects are observed in those crystals which are likely to form Schottky defect. Okay, now you see the electrons which are trapped in anion vacancies are referred to as F centers. Let us take an example of the crystal NaCl. Okay, so if the electrons are trapped in anion vacancies, that is of the chlorine side, then it impart yellow color to the crystals of NaCl. Okay, the yellow color Okay, there are other few remaining topics, like around 3 to 4 topics I want you to go through, and if you have any clarification or doubt, then you may kindly ask me. Okay.